Okay, today we're going to start our second unit on radicals. And a radical you would have experienced before. It's basically anything that has a square root. So what we're going to be looking at is simplifying, adding, subtracting, solving equations, things like that that involve things with a square root. So it could be something like a square root of a number, like 12, or it could be something that has variables, like 12x squared y cubed, or we could even get something that's a cube root or fourth root or fifth root or anything like that. So that's what we're looking at doing. So to start with, if I use the words square root, well, we have to remember that everything actually has two square roots. So if I say find the square root of 9, we actually get negative 3 and positive 3 because both of those squared both give you positive 9. So the square root of 9 is actually negative 3 and positive 3. But when we use the symbol, the square root symbol, what we're actually finding is what we call the principal root. And we typically just worry about the positive one only unless the question specifies differently. So square root of 16 we say is 4, not negative 4. And another note, a square root symbol actually has a little 2, index little 2 over top of the root to tell you that it's a square root. But since it's the most common, we don't usually write the 2. So when you see a square root by itself, the 2 is just implied. So if you do get a question that's anything different, it'll tell you otherwise. But always assume that a square root would just be the positive. So a cube root now is basically the same idea. So we know that 3 cubed equals 27. So that means if we do the cube root of 27, we'd get us back to 3. And because we're multiplying 3 times, negatives do work. So you can't have a square root of a negative number. So like square root of negative 20 doesn't exist. But the cube root of negative 20 will exist because a negative times negative would give you a negative answer. So even numbered roots like fourths and 2, 4, 6, and so on, they have to be positive, but odd number ones could be negative as well. So fourth root works the same because 2 to the fourth is 16, so that means the fourth root of 16 would give you 2. And fifth root, same idea. To do these on your calculator, you have to hit the math button, and when you scroll down, you'll see that there's a cube root button. Square root is on the main screen, but there's a cube root one, and then they also have an x root. So if you want to type in on an older calculator, if you wanted to do the fifth root of 243, you have to type in the 5 first, then do the x root, then type in 243, hit equals, and it'll give you 3. Newer calculators, you can hit that button first and plug in the 5 and the 243 afterwards. So what we're going to look at today is sort of how can we change radicals from one form to the other. And the key, it basically bases on whether you can multiply and divide these things or add and subtract. So if we use our calculator, square root of 9 is 3 and square root of 4 is 2. We know that 3 times 2 is 6. But if we go 9 times 4 under the one root together, that's the same thing as square root of 36. And we know the square root of 36 is also 6. So we can multiply, that works. And if we divide, the same rule applies. So 3 divided by 2 is 1.5. Here we get square root of 2.25, and if we do that on our calculator, we also get 1.5. So multiplying and dividing, we can actually split the roots apart into 2 different numbers or combine them into 1. But adding and subtracting doesn't work. So 3 plus 2 is 5, and we get square root of 13, which is not 5. That's 3 point something, some sort of decimal. And if we subtract, the same thing applies. 3 minus 2 is 1. Here we get square root of 5. That's going to be 2 point something. So adding, subtracting, we can't combine roots or simplify that way, but multiplying and dividing does work. So what that means is we can actually take a mixed radical and change it to an entire radical just by multiplying and dividing these numbers out. So an entire radical is something that we say the entire number is under the square root. So something like root 96 is an entire radical. A mixed radical is when we get a combination of a whole number multiplied by a square root. So 4 root 6 would be a mixed. So today what we're going to look at is converting from mixed to entire, and then tomorrow we'll look at the other way around. So what you want to do first when you convert these things, so if we take 4 root 6, what we want to do is we want to change the 4 back into a square root number. So 4 times 4 is 16. So 4 is the same thing as square root of 16. Now we can multiply root 16 times root 6, and that'll give us 96. So root 96 and 4 root 6 are the exact same thing, just one's in different form. So let's do a few more, but then we also have some variables involved. So here we got 2y, so what we want to do is we want to change that into a square root. So we got to go 2 times 2 squared would be 4, and y times y squared would be y squared. So we have 4y squared times root 3. We can multiply the numbers to get root 12y squared. Same thing happens if we have negatives. Usually the negative causes problems, so just leave it out so we won't worry about it. Change the 5 into 25. So now we have 25 times 5, so that'd be negative root 125. So that negative, just carry it along outside throughout the whole thing. And our last one, we have a half, so a half times a half is actually a quarter. And x squared times x squared will give you x to the 4th. Multiply that by 24, so we end up getting 6x to the 4th, because 24 times a quarter gives you 6. So the same sort of rules apply when you get cube roots, fourth roots, fifth roots. You just got to make sure you times that number by 3, 4, 5, and so on. So in this case, let's leave the negative out front again, and we want to change 4 into a cube root. So we go 4 times 4 is 16, times 4 again would be 64. So in this case, we would go 64 times 6. So our final answer should be negative cube root of 384. And because it's a cube root, you could actually put the negative in with the 64, and we'd get negative 384 inside the root. But that only works for cube roots, not for squared. So usually it's probably simpler just to always leave the negative on the outside and you won't get the question wrong. Okay, our next one we got 580 and then a fourth root. So we want to change that to a fourth root. So 5 times 5 times 5 times 5, do that 4 times, we get 625. And then we'd have a to the 4. So now when we multiply these things out, 625 times 2 would be 1250, a to the 4. And our last one, we got a fifth root. So we'd have 2 to the power of 5, which is 32, x to the 5. And then multiply that by 3x, so 32 times 3 is 96, and we'd have x to the 6. Okay, so you just basically take your front number, times it by itself however many times whatever the root is, and then multiply that in with the inside. So another type of question we can often get is sorting things from highest to lowest, or lowest to highest. And if you look at any of these questions, it's pretty much impossible to figure out which one's bigger unless you change them to a decimal, which works. Or we can actually change these to entire radicals, which makes it easier to compare. So the 3 root 6, we could change that to 9 and 6, which would be root 54. Do the same thing for the next one, so it would be 36 and 3, which would be 108. And root 18 can just stay the same. 2 root 7 would be 4 and 7. So that gives us root 28, and our last one would be root 49 and 2, which would be root 98. So now you can see we got them all as regular radicals, so now that's pretty easy to compare. The smallest one will be the smallest number, which would be root 18, then the root 28, then the root 54, then 98, and then 108 last. So that would be our order from lowest to highest. Okay, so it works the same, doesn't matter what the roots are. Let's actually skip B for a second. Let's go down to C. So we would do it the exact same way. So in this case, we'd have 9 and 5, which would be root 45. And I'm going to do this one a little bit different. I'm going to go 5 times 5 in my head, which is 25, times 3 would be 75. 60 is good. 2 times 2 is 4, times 11 would be 44. 1/3 times 1/3 is a ninth, times 450, so 450 divided by 9 is 50. So there's our terms, so lowest to highest in this case, 44 would be our lowest, then 45, then 50, then 60, and 75 would be our biggest one. Okay, so they're pretty easy to compare once you have them as entire radicals. To do question B, we've got fifth roots, cube roots, fourth roots, we've got all kinds of roots going on. We can't compare those. They got to be the same type of root to compare. But in this case, it's sort of a special case because they actually simplify to whole numbers. So the fifth root of 1 is just 1. 1 times 1, however many times, just gives you 1. And cube root of 27 would be negative 3. So negative 2 times negative 3 would give you 6. Fourth root of 16 ends up being 2. So 3 halves times 2 would be 3. And our last one is kind of a weird one. We've got cube root of 64, which is 4. So that would be 4 times square root of 4, which is 2. So 4 times 2 would give us 8. So in this case, we actually have 8, 4, 6, and 3. So we could put those in order. The 3 would be first, the 4 would be second, the 3 would be third, and 8 would be the biggest. Okay, so sorting, usually the best case is just change them to entire radicals or simplify them as much as you can, and then you're good to compare. So the last type of question we have is it's asking which one's not the same as the others. So in this case, you basically, by looking at them, it's hard to compare, but if we change them all to entire radicals, we should be able to see. So the first one we'd have 64x squared and 3. So 64 times 3 is 192. So 192x squared would be the first root. Do the same thing for the second one. So we'd have 9 and 24x squared. 9 times 24 is 216. So you can see those two are different. So let's keep going. We already got a 192, so that one's good. So chances are that second one is the one that's different. But let's do the last one just to be sure. So we'd have 16x squared and 12. So 16 times 12 is 192. So all three are the same except for that second one. And that's it for this first topic.